Okay, good morning. Welcome to
KidMath171.
KidMath171. So we're just finishing up. We got one more day inside this section about special functions, and this is a problem from the review exercises. What is the smallest possible value of y equals absolute value of x plus 2 plus absolute value of x minus 3, where x is a real number? Right, you understand the question?
Yeah.
All right. How do you want to go ahead on this?
Well, I think I want to graph it.
Okay.
Graph the sum and then find the smallest value.
All right. We don't have any really good way to find maximums and minimums because we haven't studied calculus yet. So graphing seems like a good way to go. And by the way, even if you had studied calculus, graphing this one would still be a good way to go.
This is minus 2. This is 3.
Okay.
So that's a little steep.
Yeah. If we're gonna graph it, let's at least try to make it look. So what does this part look like? X plus 2. What does it look like?
It's a line with slope 1. I mean this.
Just x plus absolute value of x plus 2. What does that look like?
2 lines, sort of like this.
All right. Which graph should this remind you of?
In absolute value.
Just looks like regular old absolute value. Just shift it over. Okay, so that's more like it with a slope of 1.
And then it's kind of the same thing for this one.
Okay. Okay. Kind of the same thing. Now you made a distance of 2 over here look a lot like a distance of 3 over here, and it looks like these have the same value at 0. Do they?
No.
No. But that's fine. We'll work on getting just a little bit more careful on the graphs. This one really should be over here a little bit more so that they meet kind of here.
So now we have to check the regions for their sum.
Okay.
We have to check in this region. This is a slope of minus 1. This is a slope of minus 1.
Okay.
And in this region, it's a slope of 1 and minus 1. This region, it's going to be 1 and 1.
Okay.
So now we have to regraph this.
All right.
So from minus 2, well, we need a y value, though.
How are we going to figure out the y value of the sum at minus 2?
We gotta check a point.
Okay.
Let's check minus 10.
I want to figure out the y value at minus 2.
Okay, so we can check minus 2.
Okay. So
it'll be 5. 5 at minus 2. Minus 2, minus 3, absolute. Say 5 is about here. And it's going to go up with a slope of 2.
how did you figure out it was at 5?
At the x value.
Oh, you plug it in here, you get 0.
Yeah.
And then you plug it in there, you get 5. Okay, fine. And it goes up with a slope of minus 2.
And then there's a 0 slope up. There's a 0 slope to 3.
Okay, and what's the value at 3?
It's still going to be 5.
What was the slope between minus 2 and 3?
So it's supposed to be 0. There.
Okay.
Like kind of like that.
All right. And then what happens after 3?
Then it's a slope of 2.
Okay. All right. So what's the minimum value?
Well, the minimum y value is 5.
Minimum y value is 5. It's a flat horizontal line in between x equals minus 2 and x equals 3, and that horizontal line is at y equals 5. So we have a steep slope coming down, flat horizontal line across, and then a steep slope of 2 going up the other way. So the minimum value turns out to be achieved at all of these points, and it's 5. Yeah. Pretty good. Graphing really helps us. And the only thing we need to work on, being a little bit more precise on, is just graphing with just a tiny bit more accuracy. So we want a slope of 1 and 1 going away from there, 1 and 1 going away from there, and you can see they meet a little bit more over here, not right on the axis, and then we can graph them together.
Yep.
But anyway, good job. Good job. It's a challenging problem. That was from the challenge problem section. Good job.